Good evening. I am Pranavi from CSCE section. Today I am going to uh, present a PPT on the topic breadth first search algorithm. So let's get started. Breadth first search. It is a graph traversing technique where we select a random root node or an initial node and start traversing the graph layer by layer in such a way that all the nodes and the respective child nodes are visited and are explored. Next, there are some particular rules that we need to follow during doing the BFS search. BF search. First is it follows the queue, that is a FIFO principle, first in and first out. And if we mark any node as the root, and we can start traversing from there. And after traversing all the nodes, and it drop them as completed. And if it visits an adjacent unvisited node, it mark it as done and insert it into the queue, and removes the previous vertex from the queue. In any case, if there are no adjacent vertex are found, and it iterates until all the vertices of the graph are successfully traversed, and if it is marked as completed and there are no loops caused by BFS. Next, example of BFS. First is visiting a node. Here we can easily know that visiting a node means visit a particular node or selecting a particular node. Next is exploring a node. Exploring means just visiting and just get the data from it. Next, let's see an algorithm with an example. As BFS, it follows a simple and level-based approach to solve any problem. So let's consider a binary tree, and our motto is to traverse the graph using this BFS. So before starting, we'll know the first. Let's know the main data structure. That is, what is a queue? It is a data structure which follows the FIFO principle, that is first in and first out principle. And first, it has two open both ends, where one end takes place NQ and other end and DQ. First, NQ means insertion of the data, DQ means deletion of the data. So let's see how there are the steps involved in the traversing of a graph. First step is taking an empty queue and we have to select a starting node where the BFS starts, and we should insert it into the queue. If the queue is by chance, if the queue is not empty, we have to extract the node from the queue and insert the child nodes into the queue, and we have to print the extracted node. So let's see an example of this. See here, we are assigning A as the root node, and we'll start traversing from root node. See, first print A. Here it has been a null node, and print A means insertion of the child nodes B and C. It has been inserted. Next, print B means its child nodes, that is D and E. Next, print C means F and G, the child nodes of the C, are printed. Next, inserted. Next, D. As D has no child nodes, it goes out of the queue. And same way with E, F, G. These three also get out of the get extracted from the queue and gets printed. So here we can see the end-to-end process of the breadth first search. First, here we have assigned A as the root node. Next, we have extracted a node. We have extracted A node from the queue, and we have inserted the child nodes like of A, like B and C. Next, we have printed the node A, and if the queue is not empty, uh, and it has B and C, so B and C are the first node in the queue. So if B has the child nodes, we have to insert the child nodes of the B, that is D and E, and we have to repeat these steps until the queue gets empty. And we have to notice that already visited nodes should not be visited again. Next, applications of breadth first search, that is unweighted graph. We can easily create the shortest path uh, and with possible high accuracy, and P2P networks, that is a peer-to-peer connection, which helps to require the data faster. Web crawlers, that is uh, implementation starts from the source in the web page and visits all the links from that source. Navigation system, where we can find the neighboring locations from the source location. Network broadcasting and etc. Thank you.